Hello student, today we are going to discuss recurrent neural network for sequence generation. In the last videos we have discussed what is the language modeling and machine translation. In modeling we are interested to find the next word on the basis of previous sequence of word. And in machine translations we are interested to convert the one language into the another language. So this is the difference between the language modeling and language and machine translations. We have discussed how to design a recurrent neural network for language modeling. Now today we are going to discuss how to design a recurrent neural network for machine translation. As I told you that the RNN are mainly used for three applications. One is sequence classification, sequence labeling, and sequence generation. In the case of sequence classifications, we have one output for n number of inputs. For example, sentiment classifications and the video classifications. Where in the case of sentiment analysis, you have a n number of words, and at the end you have one output, either the sentence is positive, negative, or neutral sentence. In the case of sequence labeling, we have n input and the n output. So one output for each input. We have also discussed how to design a recurrent neural network for sequence classification and sequence labeling. In sequence generations, we have n input and m outputs. So the difference among the sequence classification, sequence labeling, and sequence generation is, here we have n input and one output. In sequence labeling we have n input, n output, and in sequence generations we have n input and m output. So today we are going to discuss how to design a recurrent neural network for machine translations. We have also seen that how to convert the data in machine consumable forms in the case of sequence labeling as well as sequence classifications. So let's have a quick review. First we will find the maximum number of the unique number of words in the given database. So suppose if your unique number of words is 24, so the length of your input vector is 24, then we will assign the unique numbers to each words. Okay, so this is a way by which we will convert the entire word into the numbers that we have seen in details in the last videos. Now, so before moving forward, let's have a quick review of RNN, GRU, and LSTM. In RNN, your state ST is dependent on the previous state ST minus 1 and the input ST. Whereas in LSTM, your next state and the hidden state is depend on your previous hidden state, previous stage, and your input. Okay, and in GRU, your current state is depend on the previous state and your current input. So these are the equations that we have seen in details in the previous video when we are discussing about the RNN, GRU, and LSTM. Okay, so now we are going to use these equations. So please keep in mind that in the case of RNN, your next stage is depend on input xt and your previous state. Whereas in similarly in GRU, your next state is depend on the current input and the previous stage. And in LSTM, you will get the two output. One is hidden state and second one is your current state, which is depend on previous hidden state, previous state, and your current inputs. So in the last video we have discussed the image captioning. So now, as I told you that in the case of image classification, we have n input and one output. In the case of sequence labeling, we have n input and n output, whereas in the case of sequence generations we have n input and m output. Now suppose your task is to captioning the image. Image captioning is a process where we are interested to find the information of the image in text form. Okay, so suppose that if the input is this image, then output will be a man a man throwing a frisbee in a park. So this should be your output. So now we are going to design a recurrent neural network for the image captioning. So now this is neither a sequence labeling nor a sequence classification. So it belongs to the third category, that is sequence labeling, sequence generation. Now how? Because in the previous cases where we are that we have discussed in language modeling, we are interested to find the current word yt on the basis of previous y1 to yt minus 1. Okay, that we have discussed. But here now we are interested with our input is image I and your output is this word. Okay, so first we need a network which will encode this informations. Okay, then we need another network that will convert the informations into this text form. Okay, so here instead of this equation, our equation is we are interested to find by t when your previous input by t minus 1 is word is given and your image is given. So on the basis of this image, suppose that for example a man. So men, your in this case by 2, probability of men when the A is given and your input image is given, this given and this given. So this is our interest, where we are interested to find the probability of yt where this your previous t minus 1 is given and your image is given. Okay, so now this is your again a conditional distributions, fine. So where we are applying the softmax activation function at the output layer, which gives the probability of different words. Okay, so here we are using the convolution neural network which will encrypt the this image, or we will extract the information from this image. So we are applying the CNN, then at the end we having the FC, matlab fully connected layer 7 we have a fully connected layers and the output is S0. Okay, so now we are using one network for the image which will extract the information from the image, and your next network is for your sentence generations. What will be your next sentence? What will be your sentence? Okay, so this is your probability. Earlier the earlier model is this, your previous t minus 1 and t minus word is given and we are interested to find by t. Now here your previous t minus word and the image is given as an input, and we are interested to find the word throwing man or how. So now we have a number of options how to connect this model and this model. So the one option is this encoded image. This is your encoder. So this encode image is considered as 0 and given to the first stage of your RNN. So here we are using using CNN for extract the information from the image. So this is your encoder. Okay, and this is your decoder which decode the informations and generate the output. So first option is we are directly connected this image to your first stage, and now the output of this image is given to the next image. So although this image this layer will also have the information about the image. So this is your first options. Now you can see here your probability of by t equals to j, where j is your actual word when your previous stage and your image is given. So here your image is given and your input is also given. Now the options 2. So in option 1 we are giving the output of S0 is only to first stage, Now now we are giving the output of the CNN to this layer, to this layer, to this layer, and up to this layer. That means we are giving the output of this image to all the layers. So we can use both the options. It depends on your model. So at this time we can't say that which option is good. Sometimes the first option is good and sometimes the second option is good. So both option can be used. Okay. So now here you can see that this is your CNN. The output of CNN is given by S0 of FC7I. Now the next time, now the input of your RNN is given by, because here you can see here. So here you can see that your probability of BT is depend on the previous state ST and the and your I and your S0. Okay. Now in this example, in this option 2, your input is, now you are getting two input. One input is this and one input is this. So you are concatenating these both the inputs XT and the output of your CNN. So this is your input. This is your XT, we can say. This is your XT and this is your previous state. So as I told you earlier that in RNN, your current state is depend on the previous states as well as your current input. So the current input is your XT as well as your fully connected output of your fully connected layers. So now this is your complete architectures for the image captioning. So we are using encoder. RNN is using CNN as an encoder. The output of encoder you can give either to the each image or either only to the first stage. So this is known as the decoder. Okay. So this is the complete architectures for the for your image captioning. Now let's have a discussion how to define the 6 jar, that is data, task, model, learning algorithm, loss function, and accuracy for the for your image captioning or your sequence generation model. So now here your task is the captioning the image. Whatever image is given, you are interested to find the corresponding text description of this image. This is your task. Your data is, because we are learning supervised learning, so your data is your image xi, and your output target is your caption of the corresponding to the image. So if we have a 10,000 images in our database, so we will also have a 10,000 descriptions for the image. So suppose that if this is an input, then we will also feed the output of this image captions. Okay, so this is your data, this is your task, and the model is, this is in the model CNN. So in the CNN, your input image is given, then we will apply the CNN. It may be a FaceNet, GoogleNet, or ImageNet, RESTNet that we have discussed. Now, so after applying the CNN, you will apply the fully connected layers. Okay, and this is your CNN. This is your encoder. At the decoder, your RNN will take the output of the previous stage, that is ST-1, and your encode, because now for the first input, your input is go and this image and the output of H0. Then you will predict the A. Next time you will your input is A and the output of output is this. Okay, and you are going to predict the man. So this is your decoder. Next stage depend on the previous stage, as well as the encoded E instant for the encoded 1 hot encoding. So that means by T-1, that means 1 hot encoding of this, 1 hot encoding of this, 1 hot encoding of this. Okay. Parameter क्या रहेंगे इसके अंदर? The parameter then is same for the U, V, and W for decoders. Then because we are using the convolution layer for the encoder, so W, B, and C for the convolution layers. The loss function is same because the loss function we are using the entropy loss functions. So the so it will be calculated same as we have calculated in the previous stage. And the next is gradient descent algorithm with the back propagation we are going to use for this for the learning algorithm. Fine. Now the next is, suppose that if you are interested to convert this language, I am going home, मैं घर जा रहा हूँ. Now you are interested to convert this into this. So this is also known as the sequence to sequence problem, because this is your sequence, one sequence, and this is your another sequence. So here again we need a two encoder and decoder, two models of RNN. One is for the encoding and second one is for the decoding. The reason is I am going home, so we need a one encoder to encode this information or to extract this informations, and the extracted information then sent to the another network. Okay, another network. So here so that it will predict the next word. For example, मैं, first is मैं, then घर जा रहा हूँ, and so on, so on. So here we are using the two recurrent neural network, one as a encoder and second one as a decoder. ठीक. अब यहाँ पर जो आपका इनपुट होगा, इनपुट क्या होगा आपका, I am going home, this is your input. ठीक है, your source sentence. And the what will be your output corresponding to this, मैं घर जा रहा हूँ, this is your target output. So you will have a n number of input sentence, n number of corresponding output sentence for each inputs. So this is your data. Okay. Then this RNN, in this RNN is depend on the, because this we are representing by HT, so you depend on HT minus 1 and the current input. Okay, and at the decoder we are again using the RNN which take the ST minus 1, this, and by T minus 1. Again here E is represented by one hot encoding. That means one hot encoding of मैं घर जा रहा, घर, one hot encoding of this, one hot encoding of this, and so on. And the parameters are same for the decoders and for the encoders. We are using the same loss functions, that is entropy loss function for calculating the loss, and the gradient descent algorithm for to learn. Now one more thing that we need to that we need to discuss over here. The reason that, suppose that if the output of this layer should be whom, but if you're not getting the output of this layer whom, then you need to adjust the weight for each and every layer. तो मतलब यदि ये है कि यदि इसका आउटपुट हूं नहीं आ रहा है, because during the training time that we know the output should be whom, but if you're not getting the output whom, then what we need to do, then the back propagation algorithm what will it do? It will pass the update the gradient or the weight of each layers till here. Okay, so this way by which we will apply the learning algorithm to the sequence to sequence model. Okay. Now the one questions, I think one questions you will have one question that why we are applying two models. Suppose that यदि हम केवल हम एक RNN, यदि हम डायरेक्टली एक RNN मॉडल इसको ना देते हो, केवल डायरेक्टली एक मॉडल इसको दे दें हम RNN, और it will convert this sentence into this sentence. Okay, so the reason is we can't do this. The reason is I'm going to home, this is your English sentence. So first we need to understand this, we need to extract the informations from this sentence. Now once, because at this end the output of this layer is directly passed to the input of this layer. Right? So जब जैसे I am going home, तो ये पूरा एक सेंटेंस है, इसको इसमें किसने कन्वर्ट कर दिया, इसमें से उसने इंफॉर्मेशन को एक्सट्रैक्ट किया, और जो एक्सट्रैक्टेड इंफॉर्मेशन वो कहाँ जा रही है, इसके पास जा रही है. ठीक है, और यहाँ पर हम ये इंग्लिश नहीं है, दिस इज सम अनदर, मतलब ये हिंदी है बेसिकली, इंग्लिश टू हिंदी. ओके, सो दिस इज अ वे. नाउ इफ यू आर, नाउ द नेक्स्ट इज to convert this India, INDIA, to India. Again, we need a two model. One is we need a two model RNN for as a encoder and RNN for the decoders. So here one RNN are used to extract this informations or to encode this informations, and the encoded information is passing to this layer. Okay, and this layer then, because the first word is E, first word should be E, then when the input is E, then the first one is this dot, then your next word is dot, so then D, and so on. So again here we need two RNN model, because this is your sequence to sequence model. So we need one RNN as an encoder to extract or to encode this information, and we need second RNN to decode this information. And at the output layer we are going to apply the softmax layer. Here we are not applying the softmax layer function, because we are not interested to get the output at each layer. We are interested to get the output only at the last. Okay, so they both are same. Now this is with the option 1, where we are passing the input to the one layer, output of this network to the to only the first layer of this decoder. We can also use this layer 2 option also, where we are supposed to give the output of first encoder RNN to the all layer of your decoder RNN. Here we need to change only here. So your RNN is depend on the previous state as well as your current input. So your current input is your ST as well as your this birds. So these are the resources. Thank you.